Hi, my name is Shrey, and today I'll be explaining question 2 from LeetCode's most recent competition, 200. Question 2 is find the winner of an array game. And the way the game works is you have two elements, you compare two elements, and the larger integer remains at its position, and the smaller integer will move to the end of the array. And whenever an integer wins k consecutive rounds, that's the number you would return. So in example 1, you would return 5. So I know that still sounds a little bit confusing, but I think it would be best if I explain it through an example. So let's hop in straight into example 1. So the first thing I did when I saw this problem during the contest was I actually simulated the entire game, which wasn't the best idea, but at the time it was the only idea which came to my mind. So I basically just simulated the entire game, comparing element 0 and element 1, and then moving the smaller element to the end and checking if it's reaches k value. But while the solution was correct and gave me the correct answer, as I expected, I would get a time limit exceeded because that was not an optimal solution at all. So after a little bit thinking, I came up with a new solution, which is actually the best solution for this question. O of n time complexity and O of 1 space, so you're only looping through the array one time. So the way I did that was I declared two variables, a current winner, the number I would return at the end, and a winner count, the number of times a certain element has won. So you start off by saying, what's the greater number, 2 or 1? And 2 is greater, so that's our current winner. And the winner count for that would be 1, because it's won one time. Now you compare 2 and 3. And 3 is greater, so now our current winner is 3. And we reset the winner count to 1, because now 3 has only won one time. Just like that, we loop through the entire array. 5 is greater than 3, so our current winner is 5, winner count is 1. 5 is greater than 4, so our current winner is still 5. That was very bad, 5. Our current winner is still 5, and our winner count is now 2, which is equal to the k value which we were given. So we would just return 5. We would break out of the loop at that point and return 5. But just for more clarity, let's say that this k value is actually 3. So now you're comparing 5 and 6, and 6 is a winner, so our current winner is now 6, and the winner count of that is 1. Now you compare 6 and 7. 7 is the current winner, and the winner count is 1. So what do you do when you have 7 at the end of the array? Well, one thing to keep in mind, and probably the most important part of the question, is whenever a larger element beats a smaller element, the smaller element will go to the end of the array. So actually 1 would have gone to the end of the array, and then 3, and then 5, and then 4 and 6. So 7 would actually be at the front of the array. And starting from that point, 7 is greater than all the numbers. So 7 will always win from that point. So that's the thing you need to keep in mind. Whatever the current winner is, when you reach the end of the array, if it hasn't hit this k value yet, will be your winner. So we hit the end of the array, our current winner is 7. So even though the winner count doesn't equal 3, we're still going to return this value 7. So yeah, that's the entire question. And just for clarity purposes, I will quickly explain it in code. And maybe I'm just going to go ahead and delete this. Yeah. So the first thing we need to do is we need to declare a winner count declare to 0, and current winner declare to 0. Just standard conventional things. Next, what we do is we're using two pointers, but you're only checking each element once, and I'll explain what that means. So you set I equal to 0, so you're starting at the beginning, and then you set j equal to I plus 1. So you would compare 2 and 1 initially. The next thing you do is you say while j is less than the array length. So while j is in this loop basically, and if you have reached the end of the array and you haven't hit this k value, then that's the answer you would return. So in this while loop, you say if array of 0 is greater than array of 1, well then our current winner would be array of 0. Or actually, it's not array of 0, my bad. It's array of I and array of j, because you're gonna change these values. So current winner will equal array of I. You're gonna increment the winner count by 1. And yeah, so you're gonna increment the winner count by 1, and then you're gonna increment the j value. So 2 beats 1, so now you increment j to element 2, and 2 is less than 3. So if that isn't the case, as I explained with element 2 and 3, if 3 is greater than 2, then you want to set the current winner to array of j. And you want to reset the winner count back to 1 now. That's what I did in the visual example. I reset it every time a new element was greater than the original element. So now you want to start comparing 3 and 5. So your I value will now equal the j value. So I equals j, and then you set j equal to I plus 1. So just like that, even though you have 2 pointers, you're only actually looking at every element one time. And finally, in that while loop, you want to quickly see if you've reached the k value. So if winner count equals k, if it does, you want to return the current winner. But if that isn't the case, when I showed you when k was equal to 3, once we break out of the loop, we can just return current winner again. So I'll say break out of loop and return current winner. And I kind of forgot to label these numbers, so go ahead and do that too. 7. 8. 9 and 10. So yep, that's the entire solution. And I want to spend another moment quickly talking about time and space complexity too, because this is the most efficient solution to this problem, for Java at least. So the reason the space complexity is O of 1 is because you're not creating an array list, you're not creating an array, a hash map, hash set, you're not creating anything to store the variables in. You're only using 2 indexes. So that's why the space complexity would be O of 1. And the reason the time complexity is O of n is because you're only checking each element one time. So whatever the size of the array is, if you had 100 elements, you would only do 100 checks. And in this case, there are 7 elements, so you'd only do 7 checks. So the time complexity would be O of n. So yep, that's the entire solution to this question. If this video helped you in any way, please leave a like and subscribe. And as I said, if you have any questions, just leave them down in the comments below, and I'll see you in the next video. Thank you.